raisins in a scoop of each brand of raisin bran cereal. So on the y-axis we see the number of raisins, and on the x-axis you see the brand, and we have the number for good to go and the number of raisins for morning meal. If the mean of the data is 7 raisins, find the number of raisins in each scoop of Great for You. Okay, so this is unknown. Let me first copy the question to the board. Okay, so we know that this brand has 9 raisins, so 9 plus an unknown number for Great for You plus morning meal has 7 raisins. So this divided by 3, because we have 3 data points, is equal to 7. So the first thing we need to do is to multiply both sides of the equation by 3 to get rid of this denominator. So we multiply both sides by 3, so we get 9 plus x plus 7 equals 7 times 3, which is 9 plus x plus 7 equals 21. And now we simplify the left hand side of the equation. 9 plus 7 is 16 plus x equals 21. And now we need to isolate the x. So we subtract 16 from both sides of the equation. So we are left with x equals 21 minus 16, which means that x equals 5. Okay, so this means that Great for You has 5 raisins in each scoop of each brand. In Great for You has 5 raisins. 5 raisins, that's the number here. Let's see if this answer is the correct answer. Good. Next question. Okay. Let me first copy this to the board. Find the interquartile range IQR of the data in the dot plot below. So this dot plot shows songs on each album in Shane's collection. Okay, so this album has 7 songs. This album, she has 2 albums with 9 songs, 3 albums with 10 songs, and so on. We need to find the interquartile range in the dot plot. Okay, so first we need to order the data from least to greatest. So we have 7, we have 9, and another 9, and 10, and 10, and 10 3 times, and 11, 12, 2 times, twice, and 14. And how many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points, which mean 1, 2, 3, 4, 5. So these 2 data points are the middle, and the mean of these two data points median of the bottom half of the data, which is these 5 numbers. So this is the median of the bottom half, 9. This is the median of the bottom half, which means this is where quartile 1 ends, and now we need to find the median for the upper half of the data, which is this 12. This is the beginning of quartile 3. Which is 12. So the difference between 12 and 9 is the interquartile range, which is 3. So this is the interquartile range. The IQR is the distance from Q1 to Q3, which is 3 songs. Let's see if this is correct. A small accounting firm has 4 accountants who each earn a different salary between $15,000 and $60,000. For extra help during tax season, they hire a 5th accountant who earns $10,000. Okay, show data. How will the hiring of the 5th accountant affect the mean and the median? Okay, so before they hired the accountant, the mean was the median. That's the median. We had 4 data points, and these 2 data points are in the middle, so we need to find the mean. So the mean of these 2 data points is 55. And when we add Mark with a salary of 10,000, we now see that the median becomes this data point, which is 54. So the median has decreased by 1 from 55 to 54. The median. This is the change in the median. The median has decreased from 55 to 54. As for the mean, so the mean will be affected much more significantly, because when we have these 4 data points, the mean is it's also somewhere between, let's see, 52 plus 54 plus 56 plus 58. Okay, we can basically calculate the mean just of these and add 50. So 6 plus 6 is 12. 12 plus 8 is 20. 20 divided by 4 is 5. So the mean is also 55. Okay, so the mean is also 55 when we have only these 4 data points. But when we add 10, it will decrease much more significantly. Okay, so let's see. Both the mean and the median will decrease, but the median, no, this is not correct. The median will decrease by more than the mean. The mean will decrease by more than the median. This is the correct answer. Both the mean, and the median will decrease, but the mean will decrease by more than the median. Okay. The following data points represent the number of red candy pieces in each of Nate's bags of candy. 4, 7, 11, 11, 2, 4, 2, 5, 8. Using the data, create a histogram. Number of bags. Okay, so between 0 and 3, we don't have any bag. Okay. Between 0 and 3, we have no bag. Okay. We have one here. So one bag has between 0 and 3. How many bags are between 3 and 6? 4 and 5. So we have 2 bags between 0 and between 3 and 6. Sorry. How many bags between 6 and 9? 7 and 8. So 2 bags between 6 and 9. And between 9 and 12 we have 2. Let's see if this is correct. Between 0 and 3 we have this one. Sorry. Between 0 and 3 we have this one. Wow. We have the 2. That's it. Between 3 and 6 we have 4 and 5. Between 6 and 9 we have 7 and 8. And between 9 and 12 we have these 2, 11 and 11. Okay. The following data points represent how many push-ups Mandy did each night before bed this week. Okay, the following data points are how many push-ups: 35, 32, 34, and so on. Okay. Using this data, create a dot plot where each dot represents a night. Okay, so 31, we have 1 dot. 32, we have 1 dot. 31, okay, already represent 35, 1, 2, 3, 4, 5, 35, and 34, 1 dot. Okay, so 35, 1, 2, 3, 4, 32, 1 night, 31, 1 night, 34 night. Okay. So let's see, this histogram represents size of each house on Prince Street. Okay, so between 50 and 100 square meters, we have 4 houses with this area. How many more houses have an area between 150 and 200 meters? Okay, so there are 9 houses here in this range. There are 9 houses. Then between 250 and 300. 250 and 300. So this is 9. And 250 and 300. This is 1. So the difference is 9 minus 1, which is 8. So the answer is 8. Which of the following are accurate descriptions of the distribution below? Choose all answers that apply. This distribution has an outlier. Okay, so this is not correct because we see a bell that is quite symmetric. We don't see any value or bucket that is very distant from the other data points. So this is not correct. Option A is not correct. The distribution has a cluster from 0 to 39 guests. Here, this is a gap where there are no data points. So this is not correct as well. None of the above. The data below represents the number of customers at each Slurpee Sam's spaghetti shop. The number of customers. Okay. Which box plot correctly summarizes the data? Okay, so this data is already sorted from least to greatest. How many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5. So this is the median. So first, we need to see which box plot represents the median of 31. So they all have a median of 31. Okay. So 4 to the left and 4 to the right. Okay. So the median of the bottom half of the data here is the mean of these two data points, which is 27. So let's see, 27. So this is correct because this is 27. This is also correct. This is 27. So option C is not correct because we don't see that the quartile 1 should be here. So it begins here at 29. So this is option C is not correct. Okay, and quartile 3 is the mean of these two data points here, which is 33. This is quartile 3, and this is quartile 1. So quartile 3 should be 33. Okay. So only option B shows quartile 3 at 33. So option B is correct. Okay, so the first question, let's read the question first. Learner measured the mass of each pumpkin in his patch to the nearest tenth of a kilogram. He then created both a histogram and a box plot to display the same data. Both diagrams are shown below. So this is a histogram. And this is a box plot. So the first question, which display can be used to find how many pumpkins had masses below 0.6 kilograms? Okay, so the box plot doesn't tell us anything about the number of data points in each section of the box plot. So we know that we have no idea how many data points are below 6.0 kilograms. But here we can easily calculate, because we know that we have 5 pumpkins between 3 and 5.9 and another 4. So here we have 5 pumpkins, here we have 4 pumpkins, and we have in total 9 pumpkins below 6 kilograms. So histograms is good to tell us the number of pumpkins below 6 kilograms. Okay. Next question. Which display can be used to find that the median mass was 8 kilograms? Okay, so this is clearly shown in the box plot. The box plot shows us the median, which is 8. This is the median. So, of course, the box plot is the correct answer here. Let's see if we can also find the median in the histogram. We don't know. We have a bucket of pumpkins that weigh between 6 and 9, but we don't know the specific data points within the bucket, so we cannot calculate the median here in the histogram, so the box plot. So which display can be used to find that the median mass was 8 kilograms? The box plot. Okay. And here, the histogram. Okay, what is the shape of the distribution shown below? So we see that distribution has tail to its right. Okay, and it's not symmetrical because the curve is something like this. So it's not bell shaped. So if you, let's say the middle, it's somewhere here, and you fold it across the middle line, you will not get the right hand side overlap with the left hand side, okay, because the right hand side of the data is much lower than the left hand side of the data. Okay, so distribution is right tailed, it's not symmetrical, and it's not left tailed. So C is the correct answer. Okay, what do we need to do here? The following dot plot shows the number of strokes golf players required at each hole. Each dot represents a different player. Order the holes from least to greatest. Typical number of strokes per player. Put the graph with the least typical value on top. Okay, so the typical number on this is between 5 and 6. Okay, typical number here, so here it's between 5 and 6. Here it's between 4 and 5. And here it's between 3 and 4. So I would say put a graph with the least typical. So this is the least. Oops. So this will be on top. This is between 4 and 5. This one is between 3 and 4. This one is between 4 and 5. And this one Hank is a car salesman at EH Auto Dealer. The data below shows how many cars he sold in each of the last 9 months. Okay. Using this data, create a frequency table. So 28, how many 28s do we have? We have 3. So 28 repeats 3 times in this data set. 29, 1, 2, 3. 29 also repeats 3 times. 30 repeats 1 time. And 31 twice. 28, 1, 2, 3, 29, 1, 2, 3, 30 once and 31 twice. Okay. Determine whether the following is a statistical question. How many acorns do squirrels typically eat each day? Okay, so this is a statistical question because in order to answer this question, we need to collect many data points. Okay, typically each in a day, so we need to collect the data for many days to know the answer to this question. So this is a statistical question. Yes. This question can be answered by collecting a number of acorns, each eaten daily by different squirrels. It is statistical because it requires collecting data with variability. Okay, so okay, so not only do we need to collect data along many days, we also need to collect data about different squirrels. Okay. Find the mean absolute deviation of the data in the pictograph below. So each Sunday represents 2 Sundays. Okay. So here we have 8 Sundays, each store made on Monday. 1, 2, 3, 4, 5, 6. So here we have 12 because each of these represents 2 Sundays. 1, 2. So here we have 4, and here we have 1, 2, 3, 4 times 2 is 8 as well. So 8 plus 12 plus 4 plus 8. 8 plus 2 is 10, 10 plus 4 is 14, 14 plus 8 is 22, 2 plus 1 is 32 divided 32, oops, 32 divided by 4 is 8, so the mean of the data is 8. Okay, because we have 4 data points, 1, 2, 3, 4, and these are the values of each store, so divided by the 4 stores, we have a mean of 8. So this store has no deviation, this store has a deviation of 4, this store, because 12 minus 8 is 4, this store again, the first store has a deviation of 0 because the mean is 8 and this store sold 8 or made 8, so this store has no deviation. The second store, Scream, has a deviation of 4 because this store made 12 Sundays and the mean is 8, so 12 minus 8 is 4. This store has also a deviation 4 because they made 4 and the mean is 8, so the difference between 8 and 4 is 4. And this store, Sundays, has no deviation as well. So the mean of 0 and 4 and 4 and 0, 0 plus 4 is 4, 4 plus 4 is 8, 8 plus 0 is 8, and 8 divided by 4 is 2. So the mean absolute deviation is 2. Find the mean of the data in the dot plot below. Okay, so we have 20 plus 23 plus 25 plus 28, size of each of Mr. Sirac's classes. Okay, number of students. Okay, so one class has 20 students, the other 23, another 25, and another 28. So we need to find the mean. So we add them all up. 3 plus 5 is 8, as 8 is 16. And we have here 8 plus 96, and we need to divide it by 1, 2, 3, 4 data points. So 96 divided by 4. 80 divided by 4 is 20, and 16 divided by 4 is 4. So this is 24. Yes. So the mean is 24 students. Find the median of the data in the dot plot below. Okay, so we need to first order the data points from least to greatest. So we have 0, we have 1, we have 2 twice, we have 3 times, 3 and 3, 3. We have 4, we have 5 2 times, we have 6, and we have 7, and we have 8. How many data points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 data points, which means 1, 2, 3, 4, 5, 6. Okay, so we have 6 to the left and 6 to the right. So this here is the median because it has the same number of data points to its left and to its right. So the median is 3 points. Okay, number of stylists employed by each hair salon in Jamesville. Okay, what percent of salons in Jamesville employ 18 or fewer stylists? So, So 18 is the maximum here. So all of the salons employ 18 or fewer, because 100% of the data is 18 or below. Good. Okay, so I have completed the unit test for this unit, data and statistics. And in the next video, I'm going to take the course. I'm going to take the mastery challenge, and then I will take the course challenge for the entire 6th grade. So I will see you